Welcome back, ladies and gentlemen. Today we're going to talk about compound interest. Basically, how you can become wealthy without doing very much work at all. And I do have to take a little dose of patience, but this is one of the biggest tools on how wealthy people get even more wealthy. And you do have to have a little seed money, but let's just take a look at this. Ultimately, we're going to get a formula, and you got to be able to work that formula today. But let's take a look at these real life situations. I'm going to start with a boring one: life insurance policy. Let's just say you throw down $1,000 and you invest it at a 5.5% interest rate, and that's 5% over the course of a year. What does an account balance look like over time if that? Let's just take a very simple example at the moment, where that interest is compounded at the end of the year. So you're kind of handing your money over to a bank or something like that. They're investing it further. They're trying to make more than that 5.5% on whatever they do with your money, but they're guaranteeing you a 5.5% return on that. A couple prior skills we got to be aware of is stuff like being able to convert a percentage to a decimal and that sort of thing, and how to find the percent of a number. So in this case, let's just take a look at it after 1 year. Make it simple, okay? We're going to have $1,000 staring us in the face, and we want 5.5% added on. So what I'm going to do is I'm going to add $1,000. So the way you find a percentage of a number is you multiply it by the percent converted to a decimal. To convert a percent to a decimal, just move the decimal place over 2 spots to the left. So this would be 0.055 as a decimal. And basically what this will do is it'll take this $1,000, that's your seed money, your principal, and then add a little chunk to it. So I'm going to go 1,000 times 0.00, no, not 00, but 0.055. There we go. And that is an extra $55 for all your non-work that you just did. So that would be $1,055. Now, what happens the next year as you continue to invest with whatever company this is? Well, now our initial or our starting balance is $1,055. So we're going to have that, and then we're going to tack on a little bit more. All right. So it's going to be $1,055. That interest rate is going to apply to the earned interest from before. And now, if I do the same thing, we got let's go 1,055 plus 1,055 times 0.055. And that gets us to $1,113.02. And you'll notice that if I just added on another $55, I would be at $1,110. So we got an extra $3 over the deal. You might say, well, that's not a very big deal. Why do I care about that? Well, when you make the numbers bigger, like say instead of $1,000, now we're talking maybe $100,000. Then that $3 is not $3. It's a lot more than that. It's $300. Okay, so just that little bit of extra time and patience starts accumulating on itself. This is called compound interest, where you're earning interest on your interest on your interest on your interest year after year after year, in the real world, day after day after day. Now, what does this look like? Well, let's think about it just slightly different here. This was 100% of our money plus 5.5% of our money. So let me rephrase this just slightly, because I can rewrite this whole phrase right here as 1,000, our principal balance, times 1, representing the 100%, plus 0.055 as our gain. Okay, there's our gain. And that would get that same expression right there, would still kick out the 1,055. Now, if I played this year after year after year, well, what are we doing? We're really multiplying this piece. You're multiplying that piece towards the 1,000 repeatedly. So you can see right here, there's the 100%, and there's the 5.5% being multiplied again up against our initial investment. So I can, like, if I wanted to find year 2, the same. So if we plug this in, 1.0.055, and I wanted to show repeated multiplication 2 times, well, then I just put a little exponent up there, and then I should get that same 1113.02 number. Okay, and let's just say now that we can skip ahead, let's talk about year 20, life insurance. This is for the end of your life in the case of your death situation. So maybe you die a little early, morbid, I know, but let's say you do kick the bucket, leaving behind some money for your people. With that same guaranteed 5%, 5.5%. Let's say that happened 25 years after your policy was initiated. Let's see. Let's see what the big difference is. So now 25 times 55. We'll figure that out afterwards. But if the interest wasn't compounded, that's all you would get in addition to this. And I think this number is going to be significantly bigger. So I'm going to go 1 plus 0.055, and then I'm going to raise it on my calculator to the 25th power using the caret key. So remember, there's this button on your calculator that looks like that, or some of you might have a button that looks like, usually it's a y to the x or x to the y or something like that. That's what you would use to enter that 25th power. And that gets you 3813.39. Now, that has more than tripled your money. And if I just take 25 times 55, the amount of money that you would gain, like the first year you earn $55, the amount that you would gain just with the $55 per year, that is $1,375. And you can see right here that we've added $2,800. So we've more than doubled the difference just by allowing our interest to compound and compound upon itself. So the power of compound interest is huge. Now, unfortunately, that's not the way the real world works. We do not award interest at the end of the calendar year. Otherwise, everyone would jack up the account balances. They would get awarded that balance, and then they withdraw all that stuff. They would play that game. So instead, the way it works in the real world is interest is compounded on a daily basis. So unfortunately, what that would look like is like, what does things look like after one day? So same situation here, but what does it look like after one day? Well, that 5.5% that we started with applies to one day, so of the year. So the 5.5% is 1 year, but we're only talking about one day, so we have to divide that percent by 365, which makes a really, really small number. And basically, after day one, we've earned 15 cents of interest. Not such a big deal, and super not anything to get excited about. But we keep playing that pattern, again, using the power of exponents here. So you can see this is after day 2. I have an exponent of 2, and I'm taking that same 5.5%, dividing it by 365, but I'm going 2 days instead of 1 day, and then I get 30 cents. So we still haven't earned an extra cent. It's just 15 cents a day at the moment. And then day 3, we go on like that. Well, let's look at what, if I wanted day 5 or whatever, I just change my exponent right there. Okay. And you can see we're starting to develop a pattern. And that pattern is this. We have this thing right here. This was our initial amount. We call that our principal. This is our interest rate right there. We're going to use an R for it. This is kind of a weird one. We divided our rate by the number of days in a year, the number of times that we compounded, how many times a year was the interest awarded. Okay, so we're going to represent that with an N. And then this one, you should know, represents the 100%. That's like take your beginning balance and then add to it some percent divided by the number of times interest is compounded. So we end up with this formula right there. Okay. And this bit right here is the number of times together, like N times T is the number of times that interest is awarded. So not just time, but also the number of times per year that interest is awarded. So all those things start popping into place here. So right here we have the principal, which is the initial amount invested. We got the 1 representing 100%. We've got our rate being divided by the number of times per year that interest is awarded. All right. And then up in the top here, how many times are we going to award that interest? Well, the number of years times the number of times per year that interest is awarded. All right. And then that'll kick out the ending balance of the account. So let's just make sure that we can A, evaluate this with your calculators, and B, understand like what this would say. Okay, so firstly, I want you to pause the video and just type this in and make sure that you can type this in correctly to your calculator. I will do the same. pause there. Make sure that, so this is like 50% interest, so the number is going to be big. This gets you, and this is for 9 years, so we're going 14,096 if I did my math correctly. Hopefully I did on the fly here. Make sure that you have parentheses here. That's super important. It is easiest to do this all in one line. Caret key right there, sticking in there. Make sure that you got parentheses around where you see parentheses. You do not need to put parentheses around here, but you could. It wouldn't hurt anything. Make sure you got that. And understand that this would be like $160 invested at 50% for 9 years. Compounded, and then there's this 52 here. Well, 52 is the number of weeks in a year, so we're going to say this is compounded weekly. Okay, so that is a situation that represents that little formula. Okay, one more time. Let's make sure we can get the right answer here. This is let's do the interpretation first before we try typing it in. This would be $7,000. That's our initial amount right there, invested at 8.2%. So I'm moving that decimal over. You'll notice that it says 24 right there. That would be twice per month, compounded twice per month. 2x per month. And then you can see how many years. It looks like we got a 0.5, so we can say for 6 months. How much would that be in the end? Try typing it in. Pause the video here. Just make sure you can type in and get the right number. So I get 729.45, and that would make sense. After 6 months, you've earned a couple $100, almost $300 at an 8% interest rate. That's fair enough. So make sure we can work this formula and interpret it. Okay, let's do an example real quick, or let's talk a little bit with this N first, I guess. Annually, that would be awarding compound interest 1 time per year. This would be 2 times per year, so every 6 months. Quarterly, hey, 4 quarters. Monthly, how many months are there in a year? That would be 12. Weekly, how many weeks are there in a year? Your N value would be 52, and if it's daily, it's 365. And I will tell you, in the real world, it is always daily. So if you're dealing with stocks or a loan or something like that, or like credit card interest and that sort of thing, it is always 365 in the real world, almost always. There are very few exceptions to that. That's a stock. What do we want to do here? Let's do these bottom two here. Well, let's do the stock. Okay. Pause the video. Try to assign a value based on this situation. Assign a value to each letter. I'll read it for you if you like, and then you can pause the video. Suppose the stock averages 6.2% per year gain over 5 years. If a person initially invested $5,000, what's the total amount of in the balance after 5 years? Pause the video. Try to assign those variables. Here they are. That would be 5,000, or not, sorry, that would be our ending balance. That's what we don't know. The principal is $5,000. Our time is 5. Our rate is 0, and I'm going to write it as a decimal, 0.062, just moving that decimal 2 spots over. And the number of times per year, this is a stock. We're in the real world. So I'm going to assume that means 365. It was not said explicitly that should be 365, but that's what we're going to use because it is a stock, and that sounds like the real world to me. So let's punch it in. 5,000. Put the numbers in the right hole. 1 plus 0.062 divided by 365, and then we've got 365 times the number of years, which was 5. Type that in. Make sure you can get the same number as I do. I get 6816.94. For doing nothing for 5 years, you get an extra $1,800. Now you do have to, like in the real world, you got to be patient, but patience will eventually award you. And the earlier you start, the better things get, just overall. Here is a sad example. Let's buy a $7,000 on a used car credit card. Poor choice. All right, so you're using a credit card to buy a used car. Don't do this ever. All right, credit cards have an extremely high interest rate. Now, this one has 28.7, and we're compounding monthly. Suppose you were not able to make payments for 6 months. What's the total balance on the card at the end of that 6 months? How much of your money are you going to lose just due to interest over that half year? All right, so amount is our question mark, of course. Principal 7,000. All right, we got 0.287 is our rate. That's a big rate. We got 6 months. Now, time always has to be in years, okay? So we're going to say the time is 0.5, 0.5 years. And it said we're compounded monthly, so n is going to be 12 in this case. Okay, so type it in or set it up, and then we'll type it in. 1 plus 0.287 divided by 12, and then raised to the 12 times 0.5 right there. All right, type her in, see what we got. 7,000 times 1 plus 0.287 divided by 12, caret 12 times 0.5. Bam, we got $8,066.51. So that credit card has just earned $1,000 off of your negligence. Don't buy, try not to use credit cards. Or if you do use credit cards, pay them off immediately every month so that you don't get charged any interest whatsoever. There are people out there that carry like a $10,000 balance on their credit card month to month to month, and over the course of a year, just think that's 30%. They're paying like $3,000 in interest, roughly every year, just evaporating out of their pockets. So let's do one last one, and then I'll end the video. Let's say you have some cash lying around, and you want to buy a house for in 3 years. You figure you're going to need $45,000. So that's our goal. You can assume a 7.5. So I'm going to throw that down right there, 0.075. All right. Time was 3 years. We're going to invest in the stock market. Okay, so I'm going to throw a 365 right there because we're in the real world. We're making this as real as possible. Assuming any investment you make would be compounded daily. Okay, yep, 365. What initial amount would you have? So they're asking this question now. Okay, and then our goal would be $45,000. So our ending balance wants to be $45,000. Well, let's plug this and see what it looks like. See if we can solve this, if it's in our ability to solve this. Principal, all right, so I'm just going to leave that alone. And then 1 plus 0.075 divided by 365. And then we're going to raise that to the 3 times 365 up there in the exponent, okay? I'm going to say, Kadar, I have never solved an equation like that in my life. Well, that's okay. You see all this crap right here? That is all numbers. And it is connected to the principal by multiplication. That means that you can type in just that part times the principal, and we can see what amount we'd have to do. So I'm just going to, everything in the pink box right there, I'm just going to type into my calculator. 1 plus 0.075 divided by 365, caret, parentheses, 3 times 365, and that number is 1.25. So we got P times 1.2522, and that number goes on forever. But basically, I have P times the number equals 45,000. So it's just, a nasty version of like 3x equals 45,000, except we have this nasty decimal, 1.25. So what I'm going to do is I'm going to divide both sides of the equation by that nasty, horrible decimal, 1.2522 divided by 1.2522. And this will tell me how much I would have to originally invest to throw down in that account so that I can afford that house later on. Those things are going to cancel out. I'm just undoing multiplication with division. So I'm going to go 45,000. Divide by 1.2522. And the next number was a 9.3. So I'll keep those in there. And that means that you would have to, if you just wanted to have your money sit and be ready to buy a house in 3 years with a $45,000 initial down payment, you would have to put in account $35,934 in order to hit that $45,000 goal. So in 3 years, you would have earned $10,000 on that investment, which ain't bad. All right, I will end the video there. Your assignment is in front of you. It does involve going to Google Sheets and learning a few spreadsheet things. I will talk about those spreadsheet things upon my return, but I think it's very accessible to you at the very back side of the assignment. Have a great day.